Question number 5 is Pascal's law. What is the law? Yes, anyone? What is the statement? Pressure is same at all points at a same level. So the statement is, it states that pressure at every point on a liquid in equilibrium of rest is same, that is a container you have liquid, there are different points, point A, B, C, D, E, all these points are at a same level. So pressure at all points A, B, C, D, E is same. So Pascal's law is pressure at all points at same level, that you can write in bracket, at same level is same for liquid in equilibrium. That means liquid is at rest. That's first part. You have to prove this. We have to prove it. Again a container, liquid, imaginary cylinder, cylinder of what? Water. Inside what? Water. This is point 1, this is point 2. These 2 points are at same level. Suppose this is P1, pressure at this is P1, pressure at this point is P2. This face is what? Yes, C, face C, check. And this one is face D. Now this cylinder is in equilibrium. If it is in equilibrium, net force acting is what? 0. That means what? Force acting on this face is written as F1 is equal to force on this F2. Two forces are equal and opposite, or you can say vector F1 plus vector F2 is 0. F1 is to the right, F1 I plus F2 minus I is 0. Means what? F1 is equal to what? F2. Force on this face, yes, is how much? Force on face 1, F1 is equal to pressure into area. It is P1 into A. Force on 2, this one, is P2 into A. P1 is equal to P2. So pressure at same level remains the same. Time with you is 4 minutes to write. This is theory proof. We can have one experiment in the lab. Experimental proof. Experimental proof. There is a container, big container, and you have number of pistons marked at same level. Piston number 1, this is 1, piston number 2, piston number 3, piston number 4. So the arrangement is of this type. And you have piston 1, piston 2, piston 3 say, and piston 4. This is three-dimensional view of the same. If you have a top view for the same, it is of this type. First one, this area is how much? A. Area is A, force applied is F. It will create what pressure? Pressure, this is say point number 1. Pressure at 1, P is equal to F by A. Now the next one, yes, area is how much? Area is A by 2. How much force is required to create same pressure? Pressure at 2, P2 should also be P. Area is how much? A by 2. So when you perform this experiment in the lab, you will have to apply force equal to F by 2. Then it will be in this position. If you apply force more than this, it will move in. If you apply force less than this, it will move out. In order to maintain it at this position, because it is at a same level, pressure at same level remains same. So force applied has to be what? F by 2. Third one, yes, what is the area? Third point, 2A. Area at this point is 2A. Area is 2A. What about F3? Pressure at 3 should also be P. Area is how much? 2A. Force should be 2F, so that all ratios F by A, this is also F by A, this is also F by A. So F3 is equal to what? 2F. And the last one, what is the area? 3A. This area is 3A. Force applied F4. F4 should be equal to what? Pressure at 4 is P. Area is 3A. So force should be equal to what? 3F. So here force is F, area is A, pressure is F by A. Force is F by 2, area is A by 2. Pressure is F by 2 divided by A by 2. Again same. So all these pistons, 4 pistons will remain in this position. That is, these 4 pistons will remain in this position horizontally. This force is F. This is how much? F by 2. If you apply force more than F by 2, it will move in. If you apply force less than F by 2, liquid pressure is more, it will move out. This force is how much? 2F. Area is 2A. Pressure is F by A. If you apply force more than 2F, it will move in. If you apply force less than 2F, it will move out. So in order that all these pistons are in one position, the force for different cases comes out to be proportional to area, so that value of force to area remains same. You can perform this in hydraulic lab in engineering college, civil engineering department. You can perform this experiment. Time with you is 3 minutes.